మరేం చేయాలి నేను అమ్మ? Hi team, good morning. We'll start in just a minute or two. Okay, friends, we'll start. Let the others might join. So I'm sharing my screen and just please confirm on this too if my screen is visible and if my voice is audible. Can you please confirm in the chat box? Yep. Thank you. Thanks for confirming. Yep. No issues. So I hope we had a good session yesterday because we had discussed about parameterized constructor. Okay, and then we understood there are anything in anyhow again we had got a clear picture about the importance of objects, the purpose of objects, and how constructor sets values to objects and the exact purpose of constructor. All these things we had discussed in last couple of sessions. At the same time, we are able to understand many more things about access modifiers and then a bit of a quick understanding about packages, how access modifiers works with respect to package, all this stuff we had discussed in the last couple of sessions. Today, let's jump to the another important OOP concept. Also, I believe we had a quick coverage on encapsulation and what is encapsulation, one of the feature of OOP, principle of OOP. We came to know that encapsulation is protecting data by declaring your data private and exposing that to outside through methods. All these things we had discussed in the last couple of sessions. And we had come to know about two things, tightly encapsulated class and loosely encapsulated class. And we had seen so a quick example for all this stuff. So now another important feature of OOP is after object class encapsulation, we are discussing about inheritance. Abstraction thing I'll discuss with abstract keyword after discussing inheritance and polymorphism. So that will cover all the OOP concepts. So now what is inheritance and what are different types of inheritance? So if you ask me, it is very simple thing. Once after we are familiar with classes and objects, this is nothing, friends. Okay. So inheritance means nothing. Deriving properties of a parent class to a child class, a super class to a subclass, or a base class to a uh, normal sub-level classes. Okay, base class to derived classes otherwise, sorry. So that is simple idea. Understood, friends? So now this is a simple definition of inheritance. What is inheritance? Inheritance is nothing but deriving properties of a superclass to a subclass. In Java, we call this parent class as superclass and child class as subclass. Okay, but it's okay. Even if you say parent or child, nothing wrong. But generally, the technical terminologies we follow in Java is super and subclasses. And what is the advantage of inheritance? If you are asking a question, once we talk about this definition, then why inheritance? Why do we need inheritance? Here, inheritance avoids redundancy of data. Is a code, maybe you can say. It avoids data redundancy, a repetition of data. Okay. So there is a lot difference here. There is a quick question. There is a code redundancy and data redundancy. Code redundancy means we minimize that code redundancy through methods. Code redundancy methods. So by applying methods, what happens is wherever we are repeating that code, we minimize that by implementing methods. And here, the greatest advantage with inheritance is it avoids data redundancy. There is quite a difference between data redundancy and code redundancy. Just be clear with this, friends. Sometimes people might ask this question in interviews. Okay. Data means, in a class you have this data, right? This flower, this name, this color, something like this. The same variables, if you declare in another class, then what happens? It is data redundancy. You are using the same data again in the some other class, again in some other class, again in some other class. That becomes data redundancy. So this is where inheritance comes into the picture. What inheritance does is it avoids data redundancy. Just remember, we'll talk about it. And the advantage with with this scenario, with this concept or feature is so when you avoid data redundancy, it saves memory. And maintenance of project become easy for us. And we can also improve code reliability with inheritance because you break down your program into super class and subclass. And this approach implements a modularization concept. When you have a proper modularization, proper breakdown of code, then definitely it increases code reusability, friends. So these are the advantages with inheritance. Understood? No? For example, you take a quick example why we need inheritance. Suppose you are implementing a flower project. In that we have flower details. What is that? Flower name, flower color, flower price. Suppose there is no inheritance. Then assume that you need to create details, provide details for rose, for jasmine, for lotus. Then you should declare one class for rose, one class for jasmine, one class for lotus. And it's inside this rose class, you should declare name of flower and color of flower and price of flower or type of flower. Because roses has different types, right? So Bangalore rose or some, okay, Delhi rose or some American rose. Just take an example. I'm just giving you a quick idea. Might be whatever I'm saying might not be correct. Just a differentiation. So if we need different rose details, then we create a rose class. Similarly, jasmine. Jasmine has some name, color, and price. Again, some jasmines. There might be some big jasmines, small jasmines. Okay, something like that. If you want to display jasmine details, we create a jasmine class. Lotus details, lotus class. So if there is, assume that all these are belonging to a category of flowers, but no inheritance. If no inheritance, what we do? We should declare three variables for rose, three variables for jasmine, three variables for lotus. Then altogether, how many declarations are happening? Nine declarations. So here we are declaring same variables again and again in the same related classes because these classes belong to a category called flowers. Suppose you introduce inheritance here. Now we create one parent class or one superclass and declare all common properties of its subclasses in the parent class. What we do in inheritance, a parent class has all common properties of its subclasses. We declare all that whatever common properties. Properties means common variables, common methods which should be used by subclasses are defined in this parent class. Okay. Now what subclasses does once they inherit from this superclass, they don't need to declare these variables or these methods that are there in the superclass again. Okay. That is not needed, friends. Understood now? So whatever that is there in this superclass are automatically inherited to the subclasses. And here, except private properties, of course. Private properties are not inherited to subclasses. And whatever we have in the superclass, here you see earlier, if there is no inheritance, if we should declare separate classes, a rose class, a jasmine class, a lotus class, we should declare one copy of these three variables in all these three classes. Means nine variables are needed. Now, if you implement this super and subclass approach, just one copy of this variables is enough to, and if you declare that in the parent class, that is enough. And these are inherited to all subclasses. So now how many copies are there here? Just three copies now. Three, how many variables? Three variables. Earlier, nine declarations are needed. Now, three declarations are enough. And you saved six more declarations. Means this is what avoiding data redundancy. So, we are very clear here. If we declare these three variables, one time in rose class and another time in jasmine, another time in lotus, altogether nine variables must be declared. But with this inheritance approach, super and subclass, whatever all the common properties, common data that is needed, if you declare that in the superclass, variables or methods or whatever it is, then you don't need to redeclare that in the subclasses. And if that subclass inherits its superclass, automatically all that properties that were in the superclass are inherited to subclasses without declaring them again. And this approach avoids data redundancy. This is one of the very uh, interesting feature of inheritance, friends. This is a quick idea. Before I switch, is this clear what we had discussed so far? Are you good with this, friends? Is this clear for all of you? Why inheritance? How it avoids data redundancy? What is there in a superclass? What comes to a subclass? So generally, superclass has all what, friends? All the common properties that is needed for subclasses. And this approach avoids data redundancy. Clear now? Now, you can see here all common properties of subclasses are declared in a class called superclass. What is a superclass? Superclass is a top level class. What is a subclass? Subclass is a bottom level class. Then, how do we inherit a superclass to a subclass? We do that by using a keyword extends. We'll see examples. And another important point, we had already discussed this. What is that, friends? A private member of a superclass is not inherited to subclass. If at all, if anything that is not inherited from superclass is private. I hope this is clear for all of you friends. Understood now? And then types of inheritance. Actually, we have five types of inheritance: single inheritance, multi-level, hierarchical, multiple, and hybrid inheritance. And in this, Java doesn't support multiple inheritance. Okay, this is not supported in Java. Maybe if you ask me why, there is a situation called deadly diamond problem. What is that, friends? Deadly diamond problem. So, because of this deadly diamond problem, Java doesn't support multiple inheritance. Okay, friends. So here, what type of inheritances are supported by Java here? Java supports single inheritance, multi-level inheritance, hierarchical. Somehow you can try hybrid. Hybrid means combination of any two inheritances. But strictly, multiple inheritance is not supported by Java. Got it right, friends? So, why? Because there is a situation called deadly diamond problem. And again, you might ask a question. What is this deadly diamond problem? We will discuss that. At the end of this inheritance topic, we'll talk about it. Okay. But before that, let's start with the first one, single inheritance. Single means simple, friends. One parent, one child. Deriving a subclass from a superclass. So that is single inheritance. Deriving one subclass from one superclass is single inheritance. Now, deriving one subclass from one superclass is known as single inheritance. Okay. And multi-level means what do we do here, friends? It's simple. It goes level by level. Suppose you have a parent superclass, you derive a subclass from that. And again from that subclass, you derive one more subclass. And this continues like this. This goes level by level. This is called multi-level inheritance. Deriving a subclass from a superclass and in turn deriving another subclass from the derived class and so on is known as multi-level inheritance. Is this clear for all of you, friends? We'll see quick examples so that we get a clear picture. Okay, friends. Let's see one example for single inheritance. One parent, one child. Sorry, friends. So let us see an example. This is multi-level. We'll do an example for single inheritance. Let's do that. Let's take a new class. I just name this as a single inheritance. Okay, let's add this. And just this is test class, leave this as is. Now declare one class A. This is a so simple class to understand single inheritance. That's all, friends. Okay, you can also try this parallelly. Test this along with me, friends. If you have that set up everything ready. Now declare one more class B and say extends A. Okay, friends. So now if you see here, we had declared two classes, one superclass, one subclass. And what we are doing here, we are extending this subclass from superclass. In between this superclass A and subclass B, we have this keyword extends. This is something which establishes relation between superclass and subclass. I hope this is clear for all of you, friends. So what should I do now, friends? I should declare few variables and test this code. First, what shall I do now? Simple. Let's make a simple examples to understand this concept. Let's not complicate this. Okay, just take a simple example. Declare two variables int A, int B. Maybe if you want, you can assign it them directly. But generally, you know, right, how to declare a standard Java class. Here, don't declare this variables as private. Generally, when if you want to inherit, when usually in inheritance, if you want your variables to inherit to a subclass, then don't declare them as private. Better leave them as default or either declare them as protected. Otherwise, the best thing is in inheritance, declaring variables as protected is more recommended. Okay. So now what is that? These variables are accessible anywhere in the same package and by subclasses of other package. So that is the advantage if you declare a variable as protected. We had already discussed this very clearly. Now what you do, friends? One method to initialize these variables, one method to print these variables. That's all simple. You don't need to do anything. Now what do you do? Take one method, some public void set data. You can take any name. It's not like it should be set data. It's up to you. Get data or okay. Otherwise, input data, anything of your choice. Now initialize A and initialize B. Maybe if you ask me a question, what is that? See, how do we input values from keyboard in Java? Do you ever teach us how to input values from keyboard? So yeah, definitely. You can use something called scanner class. If you are curious to know that, I'll show you now itself, not an issue. But actually, all this reading values from keyboard and printing, all this happens at our learning level. Tomorrow, when you go and start working in any real project, this initializing from keyboard, all that, most of the time you don't see that. Only here, because we see that quite often while doing in colleges, and then once out of that college, in some learning institutes, people teach all this, right? But in a real environment, reading values, dynamic initialization from keyboard happens very rarely. We don't do that actually. In fact, if you ask me, okay, either the data comes through some kind of UI user interfaces, or otherwise it comes through some Excel formats, right? Through some different kind of data sources. Okay. But anyhow, I'll show you. If you want, I can show you now itself. There is something called scanner class. First, you should import it. Scanner is not directly there in our default package java.lang. There are many built-in packages in Java. We know about user-defined packages that com.nomtech is user-defined. But if you want to use some built-in classes, you don't need to create anything. Just simply you should import those packages. And also another second thing is you should know where these classes are there, in which package these classes are there. Again, you might ask a question. How do I know which class is in which package, Manoram? Even I am also similar to you, only friends. So initially we don't have that and idea. But as you start, you know, observing that as you keep working with them over a period of time, you understand. Oh, this package, this class is in this package, this class is in this package. That's all, friends. Okay. Now our need is scanner class. Maybe we have some of you, if you have learned Java, you have used some buffered reader class as well from the this files concept. But buffered reader is outdated. It is actually a deprecated method. Scanner is recommended. So what do you do right now? If you want input values from keyboard, sorry. So create a scanner class. But before that, if you want to create scanner object, we cannot do this outside class directly. Creating object is not possible outside class. You can do that here itself. So what you do is create. You can declare the scanner object in the instance scope. So if you want, you can say a scanner space is equal to new scanner of in brackets system dot in. Am I again bringing one subtopic now? What is that subtopic? Along with understanding the concept of single inheritance, we are also we are also learning how to input dynamically initialize in this variables of a class. You can use scanner to initialize either local variables, instance variables, or static variables, no issues. But we are just having a quick idea how to dynamically initialize variables in Java, not just instance. For anything, scanner can be used. Okay. So now what do you do? Put your cursor on this error. Why this error? If you directly create object, you get an error because your compiler doesn't recognize where this object is coming from. This is not, we didn't create any class scanner in our package, right? So your compiler will be it is ambiguous now, right? So what shall we do now? Import that scanner class, and that is available in java.util package. Just say import. So whenever you are working with Eclipse, if you are importing any class, you don't need to import like this. Simply just create object, automatically it shows an error. Put your cursor on that and automatically it will show you some all these hints and just click on that import option. You got it right. Let me just show you again. So I created object, but your compiler doesn't recognize where this class is coming from. Then what do you do? This is a tool, right? Your Eclipse will provide some suggestions. Just put your cursor on that error, and it is giving you three quick fixes available, and one is the valid quick fix. What shall we do now? This is the most recommended. Okay, second one, create a class scanner. It is now it is also suggesting by mistake if you create object without having that class, it is suggesting go and create that scanner class. And third thing, setting up your project. Sometimes there will be version issues. Then even in such cases we have these errors. So for now we are going with option one, import. Now we have imported this scanner class. And this scanner is there in which package? This is available in java.util package. And if you import couple of times, automatically you understand one thing. Scanner is a built-in class which is there in java.util package. So like this, what happens? Even though if you are not familiar with built-in classes or built-in packages, when you keep doing, when you start working with them over a period of time, you understand which package has what classes and how to use them. So don't worry about all that. For now, this is what you should do. What is that? So we need a scanner class. First import that package first and then create that object. Now there are so many methods, so many built-in methods. This is a built-in class, right? Like our user-defined class, like class A. In class A, we are declaring multiple methods like set data and display like that. Similarly, scanner is a built-in class which has many predefined methods to do dynamic initialization of data to enter value from a keyboard. Okay, so if you want to see what is there, just let me quickly show you. Say here, I am not doing a static initialization or a hard coding. I am assigning a value from keyboard system.out.println, enter A. And now I want to read this value A equal to, you should say A equal to SC dot, that's scanner dot. What shall we do, friends? This scanner class has so many methods. See here, friends. Say that scanner dot, that reference dot. You say, when you say reference dot, you can find so many methods inside the scanner class. And what is the type of value we should initialize in this method? Excuse me, friends. Here, the type of variables we should initialize is int type. So When you say that's reference dot, scanner reference dot, you find so many methods here. And which one should we choose? To input int value, we should use next int. To input byte value, we should use byte. To input short value, we should use next short. Similarly, by now you should have understood that. Like this, you have this next xxx methods. This next methods. Choose one thing which fits your requirement. Now I should initialize an int value. So simply say next int. Suppose if I should input a double value, next double. A float value, next float. A string value, just next. No, nothing else. Use just next or next line. That's all. Don't use anything else. Okay. So next int over. Similarly, input B. So what do we do again? Declare one more, enter B, and then okay, here B equal to sc dot next int over. This is how we do dynamic initialization in Java, friends. You got it right? Like scanf in C language, C in C++, if you have some idea about C and C++. And similarly, this is scanner. This is how we should do dynamic initialization in Java. Okay. So this is a quick idea about this dynamic initialization. Now we are done with this approach. Let's go to the another method. Declare one more method, public void display. Now we can speed it up. If you just understand one example of inheritance, it is almost same for all different varieties of inheritance. Approach is almost same. So system.out.println. Here we are just declaring only the necessary variables in the superclass and necessary methods in the superclass. That's all. The subclasses will inherit those members and implement some business logic or some other logic, and also utilizes these methods if needed in the subclasses. That's what happens. Okay. So the value of A is, this is coming from superclass. Just observe careful. Okay. And similarly, the value of B is, just simply say B and then treat it. Okay. That's all, friends. Now we created a superclass. And here the subtopic we involved today is a dynamic initialization. So we came to know, along with understanding the concept of inheritance, we are also seeing how to use scanner class to input values from keyboard. Okay, that's it, friends. Next, now super class is ready with all common variables and common methods. Now go to the subclass. Now this class B is extending A. This means all these non-private members except private members. All other members are inherited from A class to B class. Anyhow, for now, you don't have any private members. If at all, if any private member exists in parent class, they are not inherited to subclass. We'll see that. We'll see that after understanding this concept. So now in class B, what we do now? Now I am doing some addition in class B. I am creating a business logic, declare an instance variable into C, and then I am using one method, public void or public. If you want to return result, then don't declare void. If you don't want to return, simply say void some add. Now what I am doing here is, friends, I am not declaring this initialization, this input variables in B class. To do addition, addition of two numbers, I need two input variables A and B. And these are inherited from superclass. So these are already declared in superclass. So what I do, friends, I directly inherits them. I don't declare them again. Already they are in my superclass. So what I do, I don't declare them, just directly uses them in the subclass. No more declarations is needed in the subclass except this result variable. Even this I am declaring as instance. If you want, you can make this as local. If you declare instance, it goes into the object. If you declare as local, it goes into the method. That is the difference. If you want more clarification, I'll talk about it later, not now. Just remember now. Instance variables are declared inside class, outside method, and non-static, and these usually exist inside object, right? And local variables exist inside them. Now, I'm doing addition, C equal to A plus B, and I'm just printing it for time being. I'm not taking a separate method to print this value of C now. Just printing the value in the B, this add method itself. The sum is plus, okay, this C. That's all, friends. So this is a quick idea, small example of inheritance where we declared superclass with all this, what shall we say, friends, with all variables and public protected variables and public methods. And then we are declaring inheriting a subclass from A, and we are implementing this addition logic, and that variables whatever that is needed to do this addition are inherited from superclass, and we are directly using them in the subclass without declaring them. Here if you see, I'm not declaring A and B again in B class, and this avoids data redundancy. We have only now one copy of AB, and they are inherited to subclass like this. Okay, what do we do right now? So this is a simple idea. Now in this hierarchy, this is called inheritance hierarchy because we have a superclass and subclass. Now we should create an object. Now the question is, to which class should we create object? Can we create object for both parent, super and subclasses? Or if we create object for subclass, that is enough. What is the answer? Answer is generally in inheritance, it is recommended to create objects for subclasses. No need of creating objects for superclasses. Maybe if you ask me a question, what if I create object for superclass? Nothing happens. It's nothing. You don't have an issue. If it is needed, you can create objects for superclasses as well. But in majority of classes, in majority of cases, if you just create object for subclass, that alone, that is enough. Because subclass inherits properties of a superclass. Also, it has properties of itself in the subclass. So, creating object to subclass is usually enough for us in inheritance. But in situations where it is needed, if we should create object for superclass, still you can create it. This is a quick idea. Understood, friends? So what do you do right now? So simply create object for which one, friends? Superclass or subclass? Create object for subclass. Simply here, just to say what is it? B space B equal to new B parenthesis semicolon. Object is created. Now what shall I do now? I don't simply say B dot add here. If you do this, what happens? Do you think you can successfully do this addition? Let's see this. Now, I just called addition method without calling set data method. Display is optional. If you call it, you can see the value of A and B. If you don't call, nothing happens. But this set data is must. Without calling set data, the values of A and B are not initialized. And if they are not initialized, nothing happens. Don't worry. Why? Because this A and B already has some default values. You know, right? Just please comment in the chat box. What are the default values assigned to this A and B? What default values are assigned to A and B? You know, right? Already we had this discussion number of times. For integer, the default value is what, friends? Please comment in the chat box. It is 0. If you don't initialize anything, then your JVM will initialize something, and that something is 0. So your answer here, if you don't call set data method from superclass, then you are calling directly sum. Nothing happens. This is okay. Now run this. See here. Let's run it first. Proceed. Now the sum is 0. Why? You might be wondering. Array, I have declared, I have did addition, everything is fine. But my answer is it is showing my answer as 0. What's happening here? What is happening? You didn't call the initialization method, input method, without calling set data, where this input values will come. Yes, your JVM will provide some default values, 0. But that is not needed, right? We need some other no, good values, normal values. For that to happen, first what should you do? After creating object, on this object, what you should do is you should set data. When you say b dot set data, the set data method will initialize those instance variables a and b. Okay. And now if you call add method, it will work. Maybe if you want display is optional. If you don't call display, nothing happens. But this is must. Without calling this, that values are not initialized, and by default they have some defaults, and those default values are added. By default you get that 0. And don't wonder why, because friends, even if you are surprised, the answer should be 0 only if you don't call set data. Why? Because if you don't call set data, this A and B are not initialized, and if A and B is not initialized, this A B, this protected variables are by default is set to default values. That's 0. And that is what, when you do add, that zeros are added, and what do you get? You get 0 only. We cannot expect something else, right, friends? So this is a quick idea. Understood now? Now I anyhow leave about that. Now what did I do, friends? I call this set data method. Now this is the order. If you are, if you have any input method in the superclass, first you should call that input method on this on your subclass objects. Then call the logic method, and then call print methods. Maybe if you want here after set data, if you want, you can call display just to see the values of A and B. And add is by directly printing that sum, so no need to call any display method from subclass. Calling add method alone is enough, friends. So save this, run as Java application, proceed. And now you see this. This is coming from set data method. Enter A. So just give 10. Enter 10. You see now I am doing dynamic initialization. I am providing input from keyboard. You can see here I am entering here. Now you see it accepted 10 and 20 from keyboard. You can see from the console. And then you can see it is showing us the values as well. The value of A is 10, B is 20, and we are printing that sum here. So this is as a whole, this is the concept of inheritance. So how to declare inheritance, how to initialize from keyboard, what is scanner class, what methods exist in scanner, okay, and how to extend a subclass from a superclass, which keyword is used to do that inheritance. Okay, what happens between what happens when we inherit a subclass? How we avoid data redundancy? So there are many things we understood in this just this 35 to 40 minutes discussion. Okay. And how do we break down a program into superclass and subclass? And should we create objects for superclasses or subclasses? Which is most recommended? Okay. And order of calling methods. Right? All this we had discussed. Now this is about single inheritance, one parent, one child. Multi-level means simple. See here, just see the diagram, friends. When you look at this diagram, it's so simple, right? One superclass. So a subclass is inherited from superclass, and another subclass is inherited from a derived class, and another subclass from the subclass, like our human family structure. We don't know where it started. We know only about our grandfather, maximum grandfather. After that, if someone asks you who is your grandfather, most of us don't have an idea, friends. At most, many people can answer up to 2 generations. Okay, leave this topic aside, just giving a quick idea. But here in inheritance, if it is grandfather, you should know that. If it is grandfather, also you should know that. If it is father, also we should know that. Grandfather, also we should know that. In programming, we have to see everything. We should remember everything. We don't need to remember. Code will show us. But in reality, we don't have a clue of it. But in programming, we have a clue. So C is a subclass, B is a father or mother, and A is a grandfather or grandmother. Okay, maybe if you ask why only grandfather, why don't you use mother? Then you can take anything of your choice, friends. I'm neutral for that. I don't have any biasing. So again, suppose if you put one more class D, D is subclass, C becomes grandfather, and then grandfather and grandmother. Okay, I'm just giving a quick idea. So you can call like that, super class, something like that. Okay. So now let's quickly apply a simple scenario up to 3 levels. Maybe if you want, you can add few more levels. It's up to you. But to get to understand multi-level inheritance, it's simple thing only. Just extend your single inheritance. It's a simply extending your single inheritance, then it becomes multi-level, friends. That's all. So what do we do right now? Same program. What we do is a similar program. Let's recreate this. So here right click and say new. Okay. Right click and then say new and then class multi level. Don't get confused between multiple and multi-level. We are seeing multi-level inheritance. Okay. And then don't do anything. Now I don't want to waste much time here. Copy all this from here except superclass. Sorry, except test class. We have already a test class here and paste this. When I copy and paste these classes in this file, multi-level inheritance, you might see errors here. Why these errors? A and B are showing error. Why? Is there anything wrong here? Yes, because this A and B is already available in another file, single inheritance.java file. Once you declare any class in this package, you cannot redeclare it in other files. So this is redeclaration. This class already exists in some other file in this package. So change this class name from A to A1 and this one B to B1. So now this error is removed. So we don't have any duplicate classes now. So these are unique now. So we created A class, B class. Now I am going to create one more class. Class what, friends? We are applying multi-level inheritance. So I am taking up to 3 levels. So class C1 extends. If it should be multi-level, a quick question for all of you might be you can answer. You can comment in the chat box, friends. So should C1 extend B1 or A1? Please answer, friends. If it is multi-level inheritance, you see this is the diagram. C extends B, B extends A. So now, should this C1 extends B1 or A1? Please answer, friends. If it is multi-level inheritance, please answer in the chat box, friends. So answer is B1. Perfect. So C1 should extends B1. This is multi-level. If C1 extends A1, it is not multi-level. It is hierarchical. We are going to see that in some time now. So now what do you do? So this is multi-level. And now declare one more variable int D. Now in C class, what I am doing in B class, I did addition just for a change. I do subtraction in C class or division in C class or multiplication. Okay. So I declare one instance variable to store my result and then public void and then maybe you can take sub anything of your choice, friends. It's not like you should put sub or add. Just to understand concept, we are just having all this. Okay. Now in subclass, what should I do? D equal to. So already I have this one. I think I'll put mul. It's better. Let me take product. So in this subclass C, I'm doing product of variables inherited from A class. Now this is C, right? C extends B1. This is like a grandchild. Grandchild means grandchild can inherit properties of father as well as grandfather. So as this is a multi-level inheritance, bottom level class can have access to all top level classes. Means a bottom level class is inherited with the members of its immediate parent and its grandparent and grandparent. So now all the properties of A class and B class are inherited to C class. Again, of course, except private, if any private variables exist. But for now, we don't have that issue. So now just do the product of inherited variables of A class, that is A and B, and then using C, again C. So I'm saying A into B into C. Then this is gives you a quick idea. What is this? Now this C class, which inherits both B and A classes. So you can see now what I am doing in C class. I am adding, I am doing a product of variables A, B, C. And now if you see A and B are inherited from A class and C is inherited from B class. That's what the advantage with the subclasses here in multi-level. A bottommost class can have access to members of all top level classes. It's like a real inheritance thing. So you have a child. A child can access properties of parent and grandparent or grandparent and anything above the hierarchy. Okay, this is a quick idea, friends. So now C class can access to members of A class. A and B are inherited from A class and C is inherited from its immediate parent B class. Now using all these members above the hierarchy, I am doing a product just to give you an idea that a subclass can have access to all its top level classes. Top level means classes which are on top of this subclass. Now, what do you do right now? We should this time should we create object for C class or B class or A class? Just to test this inheritance, if we create object for C, that is alone enough, friends. So add main inside this and then create object for C class, C space C1, C1 space C equal to new C1. Now order of calling methods again. First, because even though B has this add and C has this null, first you should start calling from set data. Okay, if you don't call set data, then again all your answers are zeros. So first on the C object set with the set data. Now after that call add method. Why? This is the order you have to follow. After that call null method. Okay. Why should we follow this order of calling methods? Because once you call set data, it initializes A and B with some values. And when you call add, the addition of that A and B is happened and it stores that result into C. So C has some value after that. Okay. And once all these values are set to A, B, C, then you can do multiplication so that product comes. If you call mul before calling the set data and addition, you don't get a proper output. You might see some zeros or something. That's all. So that's why this order of calling these methods is important, friends, when you are working with inheritance. So what do you do right now? So now we had declared a multi-level inheritance example and we declared three classes A, B, C. And here the concept in Java is that a subclass can have access to all top level classes, all super classes. Okay. A subclass can have access to all members of its immediate superclass and also indirect superclasses. These are all indirect. Okay. These grand classes are right. Next one. Now run this. Right click and then run as and then run Java application. Proceed. Enter A. Because set data has some dynamic initialization, right? One and then two. Enter. But why we are not seeing value from for product means we didn't print it. Simply just add a print statement. What do you do right now? Print and then What shall I say? Simply just add the product is. Okay, plus P. Now right click and then run as and then Java application. This time you can see values from all levels. Now you can see A and B, which we input is accepting this method set data is called from A class, and then sum is coming from B class, and then product is coming from C class. And there is a dependency of one class on another here. Without calling the set data, you can't perform addition. Without calling these two methods, you can't perform multiplication. So there is a dependency here. Okay. So this is a quick idea about multi-level inheritance and single inheritance and dynamic initialization of values. All this we have seen in today's session. Tomorrow, there is one more type of inheritance to discuss, that is hierarchical. We'll complete that within just first 10 to 15 minutes. And there is another important point to discuss, that is multiple inheritance and deadly diamond issue. So we'll quickly complete that and jump to the other topic, polymorphism. Okay. Probably tomorrow we can complete some part of polymorphism as well. One more feature of OOP. Right? And then we will jump to collections topic after that. Java collections. Okay. Probably we'll try to finish as much as possible Java in this week itself. Okay, friends. That's all, friends, for today. Shall we stop here? If you have any questions, stay back, or else we will connect back tomorrow again. Thank you, friends. We'll catch again tomorrow. And Suresh, stay back. Please stay back.